So students, in the today's lecture, the intake structure. In the previous lecture, we intake structure is a civil engineering structure which should be constructed to withdraw the water from various water resources, especially from the surface water resources. So the basic function of the structure, intake structure, to help in safely withdrawing water from the source over a predetermined pool levels. Predetermined pool levels means the water level present in the source, like a reservoir or maybe a river, maybe a lake, the water level is known to us earlier, and then to discharge this water into the withdrawal conduit. Conduit means pipe. Normally it is known as withdrawal conduit or intake conduit, through which the water flows up to the treatment plant. So from resources the water will be we will take out the water, we will withdraw the water, and we will convey the water through conduits to the water treatment plant with the help of intake structure. So there are some factors to select an intake structure, like where the structure will be constructed. So the site should be near to the treatment plant so that when we are conveying the water, the length of the conduit or pipe should be less so that the cost will be less. The intake must be located in the purer zone of the source to draw the best quality of water from the source. So what will happen if we check the water quality from a particular site and it is then known to us the water quality is much purer from any other site, then the treatment water is going next to the treatment plant. So the treatment plant, the cost and the labor, the time consumed, those factors in the treatment plant will be less. So we have to check the water quality at various sites, and accordingly we have to decide the site of the structure where it will be constructed. The intake must never be located at the downstream or in the vicinity of the point of disposal of wastewater. So the structure should not be located at the downstream side towards where the water is flowing, or nearby the area where from any other source the wastewater is being disposed of. So we will get the second point and third point is related. So then we will get impure water, and it will create more load, more time, more effort and more cost to the treatment plant. The site should be such as to permit greater withdrawal of pipe water if required at a future date. So there should be available water available at the particular site more should be high so as to permit the withdrawal of water in future. Maybe it will be great because of population and industrialization, population growth and industrialization and development. So the water quantity, if more in the future, the site should fulfill the demand. means we will get more water if it is required in future. The intake must be located at a place from where it can draw the water even during the driest period. So in river or in lake or any canal or stream or even in reservoir, the water quantity for throughout all seasons, throughout a year and for all seasons, including the driest period where we will get generally less amount of water in the source, that should not happen. So this point we should also keep in mind that when the quantity of water in the source is less, the intake should withdraw the quantity of water which fulfill our demand, and it should be great then. The site will be then is great. The intake site should remain easily accessible during floods and should not get flooded. It means the intake structure, the structure, concrete structure or masonry structure, nowadays concrete structure is generally constructed. So the intake structure should remain easily accessible during also the flood condition, and it should not be get flooded, means it should not be buried under the flood water. The flood water should not be concentrated in the vicinity of the intake so as to smooth functioning and easy operation of the intake structure. So, intake structure and its intake structure is categorized in different types, like maybe it may be submerged or exposed. Submerged means beneath the water level, below the water level the structure is constructed and it will be operated. It may be wet and maybe in dry condition. According to the sources also, it can be river intake, reservoir intake, canal intake, lake intake, etc., etc. So we will see in the next few more slides the different types of intake. At the bottom of the slide, it is written some design considerations like sufficient factor of safety against external forces like heavy currents, heavy flow of the water in the source, floating materials if present in the water, submerged bodies, ice pressure in hilly and mountainous area, etc. These forces should be encountered in the design of the intake structure, concrete structure, and factor of safety sufficiently should be considered. Should have sufficient self-weight so that it does not float by upthrust of the water. So here heavy current is the main thing. Heavy flow or the upthrust force of the water should not get the intake structure floated in with the current of the water. So the self weight, the concrete weight, and with the water, the self weight of the structure should be sufficiently heavy. So accordingly, an engineer have to design the concrete structure for intake. Now first one is river intake. The diagram is shown here at the right hand side. So the river intake is located obviously in the river, in the upstream side of the river to reduce the pollution effect. Located at the middle or near to the bank of the river to get sufficient quantity of water for all seasons throughout the year. So it is located maybe middle or nearby the banks. The water level if low, where is constructed, where is a hydraulic structure? It is constructed across the river, across the source, means across the water flow, to raise the level and to divert the water to the intake structure. If the water level is low in the river, so we have to construct a where is you can at this time you can consider it is a dam. So across the river where is constructed to restrict the flow of water, and so the water level will rise and we can divert the water by some channel to the intake structure. So here entry port may be named as gates or penstocks are provided at various levels with screens to restrict the entry of floating debris. So if there are floating materials or debris are present in the with the water flow, so screens should be located. Screen should be located so that it will not enter into through the gate or to the pipe. So entry ports or gates, here it is shown penstock at high flood level and here the lowest water level, so penstock is here. So it is the port or entry gate which are provided here at various levels, and by opening it the water will go into the well. This portion is named as well. It is shown here well, wet intake well. Wet means the water is present here after opening of the gates. So it is named as intake well. So screens are also provided. Screens can be provided at the entry points or entry gates, but here screen is provided with a suction pump pipe which is connected to the pump for pumping the water. Gates are also provided with valves. Valve here it is shown. Intake well is founded, means it is constructed on sound or strong foundation below level below the scour depth. Scouring can happen in the river bed level, so it should be intake well should be founded should be constructed with concrete for over a strong foundation. Upper portion of the well is known as pump house, where a pump is fitted and it is connected with the suction pipe through which the water from the intake well will go to the treatment plant. Suction pipe is fitted with screen at the mouth of the pipe. Now second type is medium-sized river intake structure. There are basically in the previous slide we have seen an overall view of river intake structure, and here it is classified as twin well type or single well type. Can be twin well, can be single well. Let's see. Jack well should be founded on hard strata having bearing capacity greater than 450 kN per square meter. For design purpose, this data we can consider. The silt entering into the jack well will partly settle down in the bottom silt zone of the jack well in itself, or may be lifted up with the pumped waters. In pumps can easily lift the sedimented water. The jack well can be periodically cleaned manually by stopping the water entry into the well. So If there are much more silting or sedimentation of the silt in the jack well, so we sometimes manually we have to stop the entry, and we have to clean the bottom zone of the intake well, or sump well, so that more water can be stored here. Next is reservoir intake. When water is not sufficiently present at all time in the river, a dam is constructed across the river flow to store the water in the reservoir. So depends on the type of dam. So we will see one by one. First one is earth dam or earthen dam with several entry points. With several entry points, the intake is constructed at the toe of the dam. So here intake is constructed with entry points which are provided at different levels. There is one inlet port, here it is down, and here it is up for withdrawing different quantity of water which will fulfill our demand. So water is entered at different levels by opening the ports. Valves at the entry ports are operated from the gatehouse. Gatehouse is fitted at the topmost areas of the earthen dam. From this intake well, water is flowed through the conduit through which it will pass through the dam body. So it is a body of the dam. When the water is entered and stored in the intake well, through this conduit at the lower level, and this conduit is constructed within the dam body. So the water will pass through the dam body. Second one is intake well with screen, or technically it is also known as trash rack. So trash rack structure or screens are provided. This type of structure is located below minimum reservoir water level, below the minimum water level. Here it is, the minimum water level is shown. Water entry is operated through same valves from the top, which can be operated from the gatehouse, and after opening of different levels, the water will come through the screen. It will pass through the screen to the intake well, and it will then next flow to the conduit, through the conduit through the dam body. Third one is dry intake well. Water is entered through different ports and directly laid to outlet pipe So here in the intake well, water will not get stored. At different levels, ports with opening of the mouth of the ports are here, and after opening the gates or ports, the water will flow through this conduit directly, and it will go through the dam body to the next point of conveyance. So the intake well will remain dry. Outlet pipe sluiceway is provided with collar at different levels. So here it is outlet pipe. Here one more thing, stop valve is fitted and it is connected with the gatehouse. So if we want to stop the water withdrawing process through the outlet pipe, we can stop from here. Seepage from sluiceway, means this outlet pipe, cause failure of the earthen dam. So all the things are happening in the earthen dam body. So seepage, here seepage can be a problem of failure in the dam body. And regarding this, in the 7th semester design of hydraulic structure, we can discuss. Next one is submerged type of intake. Maybe of lake, maybe in lake or stream. So it is almost similar to the reservoir intake if water depth near the bank is sufficient. If the water is available at the middle portion of the river or lake or stream, then the submerged intake is constructed. If the water available not nearby the bank, it is available in the middle portion of the source to fulfill our demand, then the submerged intake may have to be constructed. So simple concrete block or rock filled timber supporting structure is there. We will see how it looks like. Opening is covered by screen, so screens are provided. Here it is written bar screen. So everywhere opening of the gauge or opening of the pipe, here screen should be provided to prevent the entry of debris. Placed in streams or lakes where they not get buried or closed by sedimentation. So silt sedimentation is a problem in the middle portion, especially of the source. So we have to find in that way where the structure should be constructed. It may be cheap and it will not create obstruction in navigation. So in the stream or lake there may be ships or small boats are navigated. So here, because of its type of structure, submerged type, the navigation will not be obstructed in any way. The opening is covered by the screen. So here, the rock-filled timber crib supporting structure is shown. Here in the red circle, it is shown that bar screen is fitted and the withdrawal conduit is opened on a timber supported rock filled structure. So cribs are made. Cribs means structure, supporting structure are made with heavy timber framework which is filled with riprap, filled with rock in a riprap or zigzag way to protect the intake pipe or withdrawal conduit against the damage. And the top of the structure is covered with bar screen or with iron grating, and all other features are same. Protected with stone pitching, stone protection. Flow velocity 0.3 meter per second at inlet, and at the outlet it is increased more as 1.5 meter per second. So here withdrawal conduit is shown and it is supported by concrete structure. Here also it is supported by concrete structure. Footbridge is provided for accessing the tower, may be of two types, wet and dry. So what is the meaning of wet intake structure and dry intake structure? So here in the intake structure, here is the water level shown. Concrete circular shell is filled with water up to the reservoir level. So up to the reservoir level, the water shell is filled. The concrete shell for water, circular shaped, is filled. Vertical inside shaft connected with vitral pipe. So here the shell is, the outer portion is known as shell. So here it is a section diagram. So the shell is fitted. Here the shell is filled and with water, first with the entry of the water. Then here also bar screen is fitted. Then inside the shell there is a vertical shaft which is actually converting to the vitral conduit or vitral pipe. So here after opening of the port which is fitted with the shell, the water will enter into the inside shaft and it will go through the vitral pipe. Openings are made in outer shell and also in the inside shaft. Gates are placed on the shafts to control the water, to control or to regulate the water, how much quantity of water we will need to control the water into the shaft. So it is a type of wet intake structure. And dry intake structure, intake tower, water is directly flowed. Here the reservoir level is shown and water is directly flowed into the inside shaft and next to the vitral conduit. So here no outside shell is constructed. It is a single type of intake tower where a simple well or inside well or vertical shaft, you can call it as vertical shaft, is constructed. So after opening of the ports, gate control ports, the water will flow to directly to the inside shaft and then to the vitral conduits. If gates are closed, no water will enter inside the tower. So it can be dry. The dry condition we will get here. So this type of structure is known as dry intake tower structure. So intake conduits are provided at different levels as we see in the diagram. Water enters by intake conduits to the well or tower and by common conduits, and vitral conduits water flows to the sluice bay tunnel or vitral conduits. Valves are provided with in intake conduits controlled from the control room for withdrawing of water. See here, intake valves are fitted with each of the intake conduits. And in machinery or gravity dam, almost same functioning is there. Different levels, screens are fitted, intake conduits or pipes and valves are fitted. The water will enter at different levels into the intake well, and from intake well the water will be withdrawn, and here also an outlet valve is fitted here. So all the tower and conduits are in the dam body.